What replica sets guarantee or tell you is the availability of specified number of identical pods. For self-healing or low distribution, or to not get into the high availability and single point failure kind of scenario, if you have one application pod and that pod fails, then the application user who's accessing that is going to go nowhere. So what we want is multiple copies, identical copies, replicas, multiple of them, right, running on our cluster. Meaning create multiple of them. If one fails, the other are there to serve the end user, take over the load. That's the story, right? So when you create a controller called as replica set, it guarantees you that number of replicas what you asked for is available. What happens is this controller is going to take this input as your desired state, and it's going to ensure that your desired state is met. Say, for example, if I tell 3 replicas is what I want, it is going to ensure at any given point of time, I have 3 replicas when I come back and look at the cluster. If now the node 2 fails and 2 pods with that node 2 go away, so my desired state was 3, but my current state of cluster is 1. So what does it need to do? It needs to steer my cluster towards my desired state, meaning add 2 more pods which have been lost. That's what your replica set does. It gives you self-healing, right? You don't need to worry about it. You don't need to get involved. You get involved only when you post your YAML file with your desired state, and then let the replica set controller keep an infinite watch loop. 2 o'clock in the night, one of the server fails, along with your replicas die along with it. You don't have to log in and go back and create those replicas on some other server. It'll automatically self-heal on some other available healthy nodes, right? And also, you usually have replicas for distribution of load as well, right? Say, for example, 1,000 users are accessing my application. 3 replicas are enough to handle the incoming load. And say we have some sale now, 1,000, more than 1,000, we have like 1,000,000 users accessing it. Those 3 replicas are not able to handle the load. So based on our traffic, we decide to scale up, add more copies of it. So I can change my desired state. I say instead of 3, give me 10. Then it is going to look at your desired state, and it's going to add that many number of pods, meaning it's going to help you scale up or scale down if you don't want, using the controller called as replica set. Otherwise, if you're just creating the pods by yourself, you had to do all of that manually. That's the reason we don't do it. We don't like to do things manually. We create controllers on top of them, which will deploy these pods and keep on watch on them. All right, that's your little story around replica set as a elementary controller we're looking at. So how do we define the replica set? What does it look like and feel like? At the bare minimum, the replica set has AKMS. Most of the objects have in the Kubernetes world that AKMS, API version, kind, metadata, and spec. This is how the replica set spec is going to look like. Under the replica set spec, you will have an integer value which defines the number of replicas what you want, called as replicas. Integer value. If you don't specify this, default option is 1 replica, 1. If you define like I want 5, 10, 20, 30, that is the number of replicas. It guarantees to you at any given point of time, you come back and look at your cluster, the desired state, the number what you asked for is available on your cluster. Guaranteeing you in a way, if things break, fixing and recreating them and self-healing them automatically. So under the spec, one of the elementary value what we'll have called as replicas, it takes integer as an input. And if I don't specify that field, default is 1 copy what it's going to create. Elementary, good. Now I'm telling my replica set controller, listen, I want at any given point of time, I come back and look at it, I need to have 5 parts. That is what I'm telling my replica set. So when a replica set controller gets created, it will ensure controllers, what do they do? If we recap the architecture, 4 things they do. Obtain what your desired state, observe what your current state, try to determine if there are any differences. If there are, reconcile them. Right? That's what they do, correct? Now, the desired state is 5. It needs to go obtain what is the current state. It needs to go see. User is asking, I need 5 pods, and it goes and looks at the cluster. There are already some pods running. For example, in our case, if I create the replica set right now, there are already some pods running. 3 pods are already running. But how does the replica set know which pods is the user talking about? How does the replica set? There can be hundreds of pods running out there. And I'm telling I need 5 pods. So how does it know which pods I'm talking about? That's the problem. So the solution for that is we give the filtering condition for replica set. We tell how to identify those pods. We do so with the help of something called as labels. We do so with something called as labels. Under the metadata, where we saw name was mandatory, now we add one more feature called as labels. Labels are simple key and value pairs. There is no fixed key or there is no fixed value. They're simple alphanumeric values which can't be larger than 63 characters, can't begin with symbols. It will be alphanumeric name or number. It can be simple key value pairs under metadata of your pod. Under name or above that, you can add something called as labels and mention those key value pairs. For example, like env is equal to prod, version is equal to v1, app is equal to red. Here, if you have 4 different applications, red, green, yellow, blue, and I want to categorize, separate them out, I can apply labels on those parts, like app is equal to red, app is equal to green, blue, and yellow, which helps in identifying or categorizing these parts. For example, if I have a rack full of books wrapped in a brown color wrapper sheet, of books belonging to different subjects, right? And if I have to go pick one book, say which belongs to a subject called as physics, maybe. So if I have hundreds of books and all of them are wrapped in a brown color wrapper sheet, I can't really identify them. I'll have to open each one of them and take a look inside it. Instead, if I had applied some sticker on top of it, some marker, and I've written like this book is physics, this is math, this is science, and geography, it's easy for me to go filter out of those 100 books and fetch that one book I want, right? Similar, I'm just trying to relate and give a real world example. So you apply labels. I told you minimum 8 lines. Now labels kind of become not mandatory, but when you make use of controllers, they become mandatory. So under metadata, we add objects like labels. And that label is what we give our replica set spec as selector. We say, listen, I want 5 pods at any given point of time. Fine. Which 5 pods? The pods which have this specific label. So making use of those labels, it goes and acquires those pods. It needs to identify, right? What is the current state? I'm telling I want 5 pods which carry label app is equal to my app. Then it goes and filters out of the hundreds of pods what we have. It goes and checks, hey, are there 5 pods with this label? If there are, 5 is what I've asked for, 5 is what it is, then the replica set controller does not need to do anything. Life is good because that is the desired state of my cluster. But 5 is what I've asked for, and the number is not matching. Right now, in my example right now, 5 is pods what I have asked for, and we don't have any of those here. Of with that label what I've asked for. Desired state is 5, current state is 0. What does it need to do? It needs to steer my cluster towards my desired state, meaning it needs to create those 5 pods. How does it create? Well, that's where you specify a pod template. In the template, it's exactly the same pod manifest file what we looked of right now. All those 500,000 lines what you could write, you will define under that pod template whatever you had. Under template, you define that. When it needs to create pods, it is going to make use of this template and create it. Earlier, you were writing the kubectl control command and telling your API server to create the pod. Now, the replica set controller will tell, hey, listen, you got to do this. Go get this pod created. That's what your replica set controllers do. They give you your self-healing and manual scaling. How does the manifest look like? This is how it looks like. Till here is elementary stuff. Kind here is replica set. R and S is capital, and it belongs to a group called as apps, version called as V1. How do I know? There are many different resources what you're going to create, which one belongs to what is the kind, what is the API version I need to make use of. We know that commands, what we can do kubectl API resources, it shows us, or we can do kubectl explain, it shows you that. So I don't need to take you there for every command. I've showed you in the pod. Same thing applies for everything else out there. Okay. And then name of the replica set, elementary, some name what you give, forget it, forget till here for now. Under replica set spec, we have 3 things: replicas, selector, template. What is the number of replicas I want any given point of time? Integer value. Don't specify, 1 is default. Then There are hundreds and thousands and millions of pods. How do I identify which three pods you're talking about? I'm telling it to match labels. Match the labels. There's labels called as app, web app. This is the key. This is the value. So whichever pods which have this label, that is what I'm referring to, is what I'm telling my replica set. It's going to make use of this information and go check which are those pods which have that labels or not. If 3 is what I've asked for, 3 is what is available, it does not need to do anything instead of just keeping an eye on it. If 3 is what I've asked for and 0 is what I get, it needs to create 3. How does it create? Makes use of the template. Now this template looks familiar to us. Here is the YAML file. Kind is replica set. Again, you can do explain, you can do API resources, recursive, all of that stuff. I'm not going to repeat all of that same thing for every command we do. Replicas, selector, template. Okay. Now I'm telling create 3 replicas for me. Which 3 replicas you're talking about? You have many pods. I'm telling the pods which have the label app is equal to tier is equal to web server. Some key, some value I make use of. But how do I know what pods, which label these pods carry? How do we know? Is we can make use of kubectl get pods command, and we can also say, hey, can you show me the labels what you carry? Show labels. It shows you what labels it has. You can also do kubectl describe pod, and it shows you that labels as well. Many different ways of letting that. But right now, if I create a replica set with 3 as my desired state, the current state of cluster is 0 because I have no pod which is having a label called as tier web server. Right now I don't have. So let me go ahead and create the replica set. Kubectl apply is a better way of doing things. Why we'll understand a little later. Make use of whatever it is there created. Just like the way we did kubectl get pods, I can also do kubectl get RS is short for replica sets. I can do replica sets as well. I can do RS as well. It shows you, listen, you have one replica set. Your current desired state is 3. Currently there are 3, and of the 3, all 3 of them are ready is what it is showing you. So I created a replica set like the way I did kubectl. Can you describe me the replica set? I can, like that way I did for pod. I can do describe for replica set as well. So it shows you the details around the replica set, telling that this is the label selector I made use of. This is the current replica counts what we have. 3 is what desired. 3 is what it is currently. Of the 3 what we have, they're running. They have not failed. And what is the template you made use of is what it tells you. It also tells you that these pods were created by this replica set controller. It triggered the creation of 3 different pods. Because when we created, 3 was my desired state, but current state was 0. So it got these 3 pods created using the template. So if I go back and look at this, kubectl will show me those pods. What do I see? I see those 3 pods. Name of my replica set and some random hash value. 3 pods have been created. Now these are not the orphan pods. These are pods which have an owner. The owner is the replica set who is keeping an eye on all of these guys. 3 is my desired state. For some reason, this pod is gone to node 2, and that node 2 fails right now. It's gone, died. I'll simulate that by deleting this pod. That pod's gone. So what happened right now? 3 was my current desired state. The current state became 2. Replica set is keeping an eye. What did it do? It went ahead and created that pod one more time. This new pod got created. What happened right now was self-healing. Automatically it got recreated. So now later in the night somewhere the server crashes, the pods die. You don't have to log in and recreate those pods somewhere. If you have created a replica set, which is keeping an eye on them, and it looks that when the node died, my pods died along with it, changing the desired state and the current state equilibrium. Desired state was 3, current was 1. It had to create some more. It went and created it. We simulated that by deleting a pod, and we see it automatically recreated to match your desired state. That is your self-healing feature. But replica sets also offer me manual way of scaling things as well. If I do this right now, get all shows me few resources out there. This is the replica set what we created. This replica set created these 3 pods out there for me. And I can do this as well. Kubectl get pods, show them, show the labels. Now we see these have those labels. This is what the labels it's going to make use of to identify it. That's your self-healing, what we saw a little bit. Now my desired state can change. Now the incoming load is too high. Manually, I can decide to change my desired state. From 3, I want to scale it up, add more replicas. How can we do that? There are different ways of doing the same thing. There are many ways. There's one way called as kubectl scale command. That is what we will make use of. It's elementary. Then there's another way called as edit. Edit that resource. I'm going to show that option to you as well. Then we also can modify the YAML file and reapply. This works if I had made use of only the apply command in the first place to create this resource. Okay, let's look at all the 3 options we have, and I'll tell you what to make use of in the exams though. Let's look at the apply first. So I created this with the help of a YAML file. While creating, I made use of an apply command. Now I want to change my desired state. For example, from 3, I want to go to 6, scaling up. So I change the YAML file. I come back and make use of apply command again to create it. It reconfigures that and it changes my desired state from 3 to 6. Meaning now when I go back and look at the pods, new pods were created because my desired state is now 6. So it needs to create 3 more pods to match my desired state. So what we did was scale up, but this was manual in nature. I understand that. And we made use of a route called as an apply, modified the existing YAML file and re-triggered. This would work only while for creating the resource if I had made use of an apply command. Why? We will understand it right now. Second way is to look at the edit command. There's another command which I'm going to introduce you to called as kubectl edit. You want to edit the resource called as web server, what we have. So what does the edit command do? So when you created this, when you posted it to the API server, it took and stored all of this information in etcd. In that etcd database and schema, it created this information out there. And apart from whatever configuration you had specified, it also injected all the other values as well, like unique ID, the creation timestamp, the owner reference, all that default things what it needs. It is all stored in your etcd. So when I say I want to edit this resource, what does it do? It fetches out the same content from your etcd and displays in which the default editor of your server. In my case, VI editor is a default. It brings out this, lets you edit. That's your edit command. It's a nice command because if I mess things up, for example, replicas needs integer, right? And I enter some junk data like this, and I want to save it. It's not going to save. It's going to say, hey, what you're doing is wrong. So that way, the edit commands are pretty cool. It tries to protect you. But edit command, like I said, brings out the details from the etcd and brings it out in the editor for you. That's what it does. And you can make use of edit command and can also modify, for example, like this. I will scale down right now. I'll shift to 2. 2 replicas is my desired state right now. I save and exit. That will be edited in my etcd. The controller is looking at it, says, oh, okay, the user desired state is right now 2, but I have 6. So what do I need to do? I need to discard 4 of them to bring the cluster towards a desired state. That's what it's going to do. That's the edit command. Now coming back to the apply command, what we made use of, and I told you if you modify the YAML file and reapply using the apply, it works. The reason it works because when you created it using the apply command in the first place, it stores annotations, as in some additional data, as comments is the English meaning of the annotation, right? So it stores something called as last applied configuration. So it looks at that configuration and reconfigures itself. This gets automatically created, this last applied configuration, when you create any resource using the apply command. If you had done that using the create command, this last applied configuration will not be stored. And then if you modify the YAML file and try to recreate that one more time, it's going to give you an error that, hey, it's already created, I can't do it one more time. And then the option you have is to delete and recreate. But if you make use of apply, it lets you change few subtle things and reconfigure it. That's the reason I said apply is the used recommended way you should make use of it. That's the apply, the third option what we saw. That's the edit we have changed right now. That's the second option. I'm going to save it It says edited. Now go back and look at kubectl, show me the desired state. It's set to 2. So what happened if I go back and look at the pods? Few pods are trimmed down. The pods are removed randomly to bring to what your desired state is. So we saw the scale up, we saw the scale down as well. Now, one question which most frequently comes up is, hey, when you're scaling down, what if that pod was serving the end user? What happens to that? So like the way we understood the birth of pod, we need to understand the death of pod as well. So what usually happens is when you scale down, when you terminate a pod, the pod does not get killed right away. The first thing it does, it sends a termination hook. It says, okay, you got to back up. The moment the termination hook is sent to that particular pod, the ready flag, which if I look at this, if I just do kubectl describe, I'm trying to explain you one more concept when you're trying to look at something else so that we kind of understand it better. Pod goes through series of conditions where it tells you there's a ready status flag, Boolean object is set to true. That's when this pod is ready to accept traffic. That's when it shows here ready 1 out of 1, right? So when I say I want to scale down, meaning when I want to kill a pod, the termination hook is sent to it. First thing it does, it sets this flag to false. It makes it not ready. So what happens when it's set to false is no new traffic comes to this pod. So first it prevents new traffic from coming to that pod. Once that is taken care of if there's an in-flight transaction out there, which the pod is currently serving, which needs to get killed right now, which needs to die, it is not going to kill it right away. By design, by default, it waits for 30 seconds, maximum of 30 seconds. That is called as termination grace period seconds. Can we change it? Of course, you can do all of that, but 30 seconds is the default. Now it's going to wait for your application, that in-flight transaction, what you have to finish. If it finishes within 30 seconds, the moment it finishes, the pod shuts down. That's what it does. So the in-flight transaction is kind of safe. No traffic, new traffic doesn't come, that is prevented. And then whatever is running, it waits for it for 30 seconds. And if it still runs after 30 seconds as well, it's going to kill that. Stop is what it does by default. If you're still continuing, it's going to kill and get out of there. Then the user will find disruption. Otherwise, usually the applications don't take more than 30 seconds to respond back. If that is the story, the moment it responds back in a millisecond or two, then once that process, that in-flight transaction is completed, it's going to shut down and terminate the pod. That's the death of your pod. So that way your transactions are safer. If it goes beyond 30, then yes, it is not. Then as part of your desired state, when you set up, there's also one more option called as termination grace period seconds. You can specify that and increase it again based on your application. Well, I try to explain you one more concept where we're looking at it. But that is your scale down termination of your pods. So we looked at the edit way. We looked at the apply way. Let's look at one more option called as kubectl scale command. This is usually what we make use of. Scale command, which lets you scale your application up or down. I can say, hey, listen, I want to scale. Scale what? Type. That is ReplicaSet, which there can be hundreds of ReplicaSet. Which one are you talking about? Well, I'm referring to this ReplicaSet by the name web server. Then what is the replicas you want? I want 9, and I can scale up like this. My desired set change. What happens? New containers are getting created right now. All right. That is your scale command. That is your elementary controller called as ReplicaSet. What it gave me was self-healing, and that is automatic out of the box. And it also gave me something called as manual scaling. That's what my ReplicaSets did. DaemonSet is going to guarantee me that a pod runs on every node of my cluster. How is the pod spec going to look like? Just like the way we've created deployment ReplicaSet, we create a kind called as DaemonSet. But there, when I say the kind as DaemonSet, I don't have to give the number of replicas I want. Kubernetes understands the moment you've created DaemonSet, the DaemonSet controller knows two things. What? The number of replicas is equal to the number of nodes I have in cluster, and also equals to 1 pod per node. Daemon as a service, like I install Docker and running as a service, or the kubelet, SSH, whatever is running on your service as a daemon, exactly this application is going to run on every node of my cluster. I don't have to give a replica count out there. The replica count, the desired state is automatically set to number of nodes you have. After a year, I add 2 more nodes out there, and I have created a daemon set controller. What is going to happen? Daemon set controller's desired state right now is 3 because 3 nodes what I have. I add 5, 6 different nodes out there. That desired state is going to change, and it's not going to match your current state. New nodes got added. The desired state from 3 changed to 6, but there are only 3 pods out there. Daemon set is going to take care of creating those pods on all of those nodes out there. Makes it easy for us. The use case is when you want to have a pod, a copy of your pod running on all of the nodes of your cluster, you don't create that as deployment controller. You create that same pod with the help of another controller called as daemon set. Now, one way we looked at it is static pod. That's the manual way of it. We don't like to do that, but if they really want to do it, you can do it. We have seen how to do that. Otherwise, we create and run as what? As daemon sets. What are the typical use cases of daemon set? Usually, if you're running your log collection daemons on every node of your cluster, or you want to run some monitoring like your Prometheus, we can make use of daemon set. Daemon set, the kind what we're trying to create is what? Daemon set. Job of daemon set to give me one pod running on all of the node of my cluster any given point of time. Node adds after 2 years, I don't have to worry about it. Automatically, the pod will be created. How does it know which pod to create, how to create? The kind what I've created is daemon set. And if I go back and bring you the deployment and the replica set pod manifest, what we looked at it, daemon set also looks similar to us. The kind is only different. Here it is daemon set, here it is deployment. Metadata, the information about the name of your daemon set, named as web server here. Spec also looks similar, but when we look at the spec of deployment, we have an options of replicas. When we look at the option of daemon set, replica is not there. That's the only difference. Other than that, you have selectors, you have template. When we create that, when the node add joins after 10 years, how does the Kubernetes know where the pod to be get added? How it should add? Template is here. There are 100,000 pods running on that particular node. I mean, you can't really run. I'm just giving an example. How does it identify? Selector is here. Same concept of what we looked at earlier is just that daemon set controller is giving to give me when my use case is subtle different. When I want to have this particular pod running on every node of my cluster, I make use of a kind called as daemon set. How can I do? One is the YAML file, and we're going to take a look at that. I'm going to take a look at this YAML file. But before we go there, I'm going to introduce to another new concept. Let me undo the few lines what I deleted. I added something called as tolerations. We are going to talk about taints and toleration in detail right now, just for a little bit of understanding purpose, right? Our master can also deploy pods. It can also run pods, user pods. So far, I created the deployment. We added 20, 100 replicas out there, and we never was a pod got created on the master node. All of them were going on worker 1 or worker 2, right? How did that happen? Master can also run. Why did not my scheduler choose this particular node out there? Why did not it choose the master node? By design, as a best practice, your master should not be running user workload. Why? Because master already has a lot of work to do. That's etcd going on there to store your database out there. There's API server constantly working. There's controllers. There is your scheduler. It is already doing a lot of stuff, and we do not want to overload our master server as well with the user workload. But that does not mean you cannot. You can if you really want to. But how are we preventing it? We are preventing it by applying an additional lock to our cluster. We did not do that. How did it happen? When I did the bootstrap of my cluster, what did bootstrap process do? It marked my master node with something called as a taint. Say, for example, in my office, I have multiple conference rooms, and I want to reserve one conference room for myself, for my team. Okay. So now anybody in the office who can walk inside, who has access to the main gate, comes inside the floor, can go into that conference room, right? Because they've authenticated, they've authorized, the security guard is let them inside. They can come inside and they can pick and choose wherever they want to go. But what I do, I'm the smart guy, I want to reserve that particular conference room for myself. I apply another lock, maybe some fingerprint lock out there. right? And only people, only my team, whom I give that extra, the passcode or the key to key in and go inside that conference room, can access it. Otherwise, that room is locked for others. Others will come try to open it. They'll say, okay, the door is locked. They'll not even look at it. They'll go somewhere else. Similar concept. I have the master node out there. I can taint it with something called as effect called as a no schedule. I'm telling the scheduler, there is this node out there. I have applied a taint. Like a special lock I have applied. Don't open the door for anybody else. Even though they're authenticated, they're good pods, they can be created here. Fine. Nobody's coming here. How did I do that? Tainting. By universally repelling everybody, sending them away by not coming. And that is the reason whatever number of replicas what we added so far, none of them got created were in our master node. All of them were going somewhere else. Node 1, node 2, node 3, wherever they were, never went to master. Now I have a use case where I want to monitor even master as well. So I want the pod to be created where on the master as well. What do? I have to give that key to that pod. The employee have to give him the password. Key in that you can go inside. There's a special key I have there. Whatever the key value I make use of, whatever the lock I have applied, I give the key. And that's exactly what we are doing as well. Where in the YAML file. Right now, if I don't apply this toleration under the spec and I create the pod this way, it is only going to go to worker node and worker node 1 and node 2 because by default they can't go to master. Master has a special lock. I want them to go to master as well. Under the pod spec, I create something called as toleration. Special pass. The key I'm giving to my pod, telling I know there's a lock out there, taint out there. Taints we apply on node, tolerations we apply to pod. In detail, we will look at taints and toleration. Now that when we're looking at daemon set, I introduce you to a new concept where we have kept it away. The special key we are giving here, whatever the key we made use of to lock this guy out. And I'm telling you, there is a taint out there with this particular key and this effect, you can tolerate. Now, the pod will also get created where? On my master. If I did not have this taint, I did not need to give the toleration, right? Taints and toleration is a new concept we're trying to. We are going to look at daemon set right now. We are going to create the daemon set. I have not given the replica account, and we are going to see the 3 pods will get created. Let's go and create this. Let's go ahead and create this. Kubectl get all. We see something called as what? A daemon set got created. What can we do to get more information? We already know. Kubectl get short for daemon set is DS. DS or daemon set, whatever you want to type, the name of that. It's going to give you a little information. I want more information. Fine, no problem. Describe. It's going to give you a little bit of more information, right? Kubectl get nodes. How many nodes do I have right now? I have 3 nodes, and as a reason of that, 3 pods got created. But are these running on every 3 nodes of my cluster? I don't know. Kubectl get pods. 3 pods are running, very nice. How do I see the node information? -o wide tells me that 3 different nodes I have. I have 3 different pods got created out there. Kubectl create describe is what we create daemon set is what we did, and we could make use of the and created a daemon set. Stateful sets. What are these? Well, there's another controller, just like the way we saw daemon sets, deployment, replica sets, many different controllers out there. There is one controller called a StatefulSet for our stateful applications, where we have certain applications which needs certain order in what we deploy. For example, let's take a look at one example real quick. Let me open a notepad. I want to have unique identity for my replicas. Say, for example, the stateless application, the web servers, the application servers, what we were deploying so far, we had multiple replicas. We did not worry about their state, as in the data per se, right? So if I have maybe a database and I say 3 replicas, and if all the 3 replicas are pointing towards 1 DB, one database itself, or one volume on which my database is set up, right? There's going to be a major mess. Reason, 3 different databases is what I wanted, but 3 different pods I have, replicas I have, all of them are pointing to the one database, one volume itself. When I create them as deployment, they are all going to write to the same volume what we have. So there's going to be data corruption. So we can't make use of a deployment controller to set up stateful applications like databases. Let me reiterate and put it in different words for you. Say, for example, if I need to set up replica of my databases, what do we usually do? Normal scenario. Say my Progress DB or my whatever database, MySQL maybe. Okay, I need 3 replicas. So we don't take 3 copies of it and just create 3 replicas out of it. What we do is we set up first DB as master, right? And then we set up the second one as slave, second DB, and we also ensure continuous replication setup. And we also have another standby. That will also be another slave what we set up. 3 different individual databases what we'll have, which will of course read from master and keep in sync. So slaves and master are all unique. They're all not identical copies. They're all unique in their own way. Here is the scenario. And that's the concept I wanted to explain to you real shortly. So we want to set up, this is the setup what they've asked me to. They'll say create a database. Okay, I will go to my first server and I create one DB master. We'll call it as master. All right. Now this is the DB where all my apps are going to write to. My application is going to connect to this, which needs to be available in the read write mode. Good. Then I can't have a single copy running out there. If there is a failure, it's going to be a problem. So we don't want to get to the single point of failure, database down, everything is down. We want to have active or warm or hot standbys available for disaster recovery. So I need to set up replicas, slaves. Cloning is what I need to do, right? So what do I do from the high availability point of view? I will then need to set up slaves. Usually you'll have more than one slaves. So when you have, this is also another unique DB, we'll have slave 1 and we'll have slave 2 maybe. Now slave 1 and slave 2, they don't talk to your end users. They continuously replicate data from master, and they are not open to everyone in the read write mode. They're usually in the read only mode. We don't want dirty writes to happen. So these 2 guys will be running in read only mode, meaning users can query data from these databases. We are always in sync with master, but for writes, you go to master. So from this way, you're not corrupting the data. This is how my application is set up. Okay. So how do you do it? Is you set up master first. First you set up the master. You do what you have to do. Then you have to do clone the data from. I'm going to remove this here. We understand what we're talking about. I need to clone the data. So the DBAs here can understand that. We set up replications, right? Whatever MySQL commands you run MySQL replica command and you clone the data. First time what you do, you take the snapshot, maybe the disk mirror fracture, what you do, you clone your disks and fracture it, or take a DB backup, restore it, whatever you do, you clone the copy and you copy exactly from master and make it as a slave. And then what do you do? Once you've done that, you need the data to be always in sync. So you enable continuous replication, right? At the database level. So it reads the data, whatever writes are happening to master are also percolating, are also in sync with your slave. You need to set up continuous replication from your master. And then once all the transactions, what's happening in the master are also replicated on the slave, that's when you open up your slave in read-only mode so people can read from it. And of course, the continuous replication is set up. Maybe there's little latency based on how far they are, what the bandwidth they share and stuff like that. And which you are okay with, right? You don't have too much of latency, but of course you'll have parameters design on what kind of latency you're okay with and stuff like that. And you have enabled continuous replication sync here. Good. And then you need one more database. So we'll set up slave 2. Again, you don't want to burden your master. Instead of going back to master, slave 1 is anyway ready. And it is continuously in sync and it is having the same data as master. So I can also now clone slave 2 from slave 1 to not put burden on my master. Once slave 2 is cloned from slave 1, I will enable continuous replication from master, read from master. So the data is getting returned to master. It is syncing continuously to slave 1 and slave 2 as well. If one goes on, other can take, others go down. High availability paradigm is what we're looking at. Right? So if you look at the flow right now, I needed the master to come up first, and then I had to do whatever configs I had to do. Then I had to set up my slave to come up. Then I had to do continuous replication, ensure it is up and ready. Then I had to make use of the slave 1 to set up the slave 2, and then enable continuous replication from master. All right. So my slave 1 and 2 needs to know the master's address to enable the continuous application needs to talk to it. Now, if I want to make use of my pods to do this, make use of this and deploy it, what do I do? If I make use of deployment, what we know so far. So if I create a pod template in that I say MySQL and and I will say 3 replicas and I create it, what's going to happen? I am not guaranteed an ordered fashion. What is going to happen? All the 3 pods are going to get created at the same time, 3 replicas. But that's not what I wanted. I want my master to come up first. Once that is ready, then I want slave 1 to come up. And then I wanted my slave 2 to come up. I wanted a ordered fashion in which my pods needed to be scheduled. I made use of deployment controller. It guarantees me self-healing. It gave me 3 replicas out there randomly. And it also named them randomly. We want to designate one pod as master and others are slave. So we need to choose one of the name, right, and configure it. But what happens is when you create a deployment, it gives random names. Maybe, okay, I will take that random name and I will add that information to my slave 1 and slave 2 configuration. Listen, this is the guy who is the master. You need to sync the data from him. And what happens in between? That pod fails. That pod fails, the pod comes back up because of self-healing feature, but the pod comes back up with a new name. Now, slave 1 and slave 2 don't know where to go because master whom we are configured is no longer available out there. The new one gets a new name or the new IP address. The slaves are in panic and they go out of sync. So what we also need, not only ordered graceful deployment, we also need static host names for the pods. Even sticky identity is applied to the pods. The pods fail and come back. They should have same names, same identity, where your pods will retain that. And we want the ordered, graceful way of rolling out and rolling back. One comes up, then second, then third, and stuff like that. So this controller called a StatefulSet gives that to you. It gives you ordered, graceful deployment. They're similar to your deployment. They give you scaling feature. They give you rolling out, rolling back, self-healing. Story is all the same, similar, not the same. On top of it, what do they do? What they create when they create the parts, they create in a sequential order. Point number one. That helps in the setup what we are looking at. Like I want master to come up, then slave, then slave one, slave two, and stuff like that. So it guarantees me that pods are created in an order. M1 comes up, then slave one, then slave two, stuff like that. And it also maintains an identity. How does it do? It gives the unique name to each pod. We call that as ordinal index, starting from 0, whatever the name of your stateful set is. It's going to make use of that for your pod name. -0 will be your first pod. -1 will be your second pod. -3 or 2 will be your third pod. The names of the pods will be unique. Now if MySQL is a stateful set name I make use of, the first pod name is going to be MySQL-0. I configure that in my slave 1 and slave 2. The pod fails, the master pod fails, it gets replaced, goes on some other node. When it comes back up, it's going to come back with the same name. It's going to come back with the same identity, same name. That is the advantage of stateful set. Again, it depends on your application, not all the applications. The stateful applications only we need to make use of stateful set controller. Stateful sets. And it tells you what stateful set is manage stateful applications. Right? Manages the deployment and scaling of set of parts and provide guarantee about ordering and uniqueness of these parts. Uniqueness how? With the help of ordinal index. Right? Like a deployment, stateful set manages pods that are based on identical container spec. Unlike a deployment, it maintains a sticky identity of each pods. Right? So scroll down a little bit, tells you stateful set are valuable for applications that require one or more following. Like you need stable, unique network identifier, stable percentage, ordered, graceful deployment. So when you want, like the concept we looked at master, slave, and stuff like that, is what you make use of stateful sets. All right. Now, there's another concept called as headless service, which we have to make use of with the help of stateful set. What is that? Now, I want my pod slave 1 to talk to my master. Slave 1 to talk to my master. And we told it's going to give you the name of the stateful set and -0. Like if, for example, stateful set pod was my name, MySQL-0 will be my first pod. If I want to talk to it, one pod, slave one pod needs to talk to the slave one will be called as MySQL-1. It needs to talk to this and it makes use of pod names. Things are not going to work. Why things are not going to work? Because when you just create a pod, your DNS records will not be created. You have a cluster DNS server, core DNS running out there. Let me quickly show you that. kubectl get pods. There's core DNS, internal DNS server running, correct? If we do kubectl, show me the service. As we see, here is the service kubedns. Okay. If I open the config file, warlib kubelet config.yaml, all the kubelets are configured with this guy where it tells you this is your DNS server 10.96.0.10. That's my cluster IP for my DNS server. It's going to route to me core DNS pods. So all of your pods are pre-configured to look at your cluster DNS server for resolving names. Okay, that is how it resolves name. And I said MySQL-0 wants to talk to MySQL-1. We make use of pod names. What's going to happen? It's not going nowhere because DNS records don't get created when you just create a pod. I mean, if you really want to create, you need to specify some more options to create, like subdomain and host name as a pod spec. It will create. Default behavior, it will not create. But when will it create? It will give you a DNS name when you create a service. Service gives us the IP, port number, and DNS name. DNS records get automatically created. Correct? Now, this is the story. I want my slave to talk to my master with the help of names. Names are going to be unique, but when you just create a pod, it is not going to create a DNS record for you. You can create a DNS record when you specify under your pod spec your subdomain and host name, which you can under your pod spec, then it is going to create. Or when you create stateful sets, what do you specify? You specify a headless service name. Here, the service what I want is just to create the DNS records for me. I don't want it to load balance. So you need to create a service. It's exactly same. The only difference is the cluster IP is set to none. Same to my cluster IP. It's going to give me a cluster IP. I don't want that IP. I don't want you to load balance. All I want you to create this DNS records so that my other pods can talk to other pods with the help of pod names. So when you create a stateful set, you need to mention which service you need to make use of. When you say stateful set controller, it makes use of the service name. The pods get the name as in like the service and your namespace dot cluster dot local. That is how they get the names. So that's the headless service where the cluster IP is set to none, where you don't want it to load balance. You want those DNS records to be created. You make use of stateful set. All right. And again, everything else apart from that is similar. Then we also see one more thing called as volume claim template. So when I created a deployment, volume claim PVCs. So when I create a deployment under my spec, volume spec, if I say PVC and claim name, whatever claim is attached to whichever volume, that is the volume is made available for all the replicas I have. Correct? In the deployment world, three replicas are pointing towards the same volume because the template is same. But here, 3 copies of the database I have are 3 different databases, 3 different volumes is what I want. So we also get introduced to something in StatefulSet called as volume claim template if you want unique volumes. So the same story. What story? If you look at this, it's exactly your claim, PVC, right? Under spec access mode, storage class to dynamically create. And if you want to request what storage, exactly the same PVC, it's just that it is going to create it as a template in the stateful set. So now what is it going to do? When you've given 3 replicas, it's going to create 3 volumes. 3 claim names are going to come up here. Whatever the storage class you have defined, it is going to generate 3 different volumes of 1 GB each, and it will have sticky identity again. First volume will be www-0, which will be attached to your first pod, 1 to second pod, 2 to the third pod. That way. That is your stateful set. From the exam point of view, we don't need to worry about it. The concept is what I wanted you to understand. Furthering from here, real quick, if I go to MySQL, set up a stateful database, run a replicated stateful application. As an example, if you look at it, it's beautiful. It tells you how to set up a MySQL DB. All right. So what they're doing is creating a config map. They say if it's primary database, then they want the configuration to be in the read write mode. If it is a replica, it needs to be in the read only mode. They're making use of a concept of ordinal index. So if you scroll up, they're running some command init container and they're setting things up. They're telling, hey, if the name of this particular pod is starting with 0, that means this guy is primary. It's equal to 0, then it is primary. If it is equal to something else, it is a replica. So you're making use of some logic here to decide which is master, which is slave, and this is going to be the master. If it is slave, clone it. They've configured it here. Quite lengthy stuff. And if you want to set up MySQL DB, you need to look at this as an example and read through it. That is your stateful set, and that is your headless service as well.
Thank you for watching this video. Now, all you need to do is click the link in the description below, or if you're just starting out, type k21academy.com/cka02 into your browser. Once you're on the page, enter your name, your email ID, and your phone number. Then click on register now. Now, here you will be redirected to a thank you page where you can easily add the session to your Google or Apple Calendar. This is your chance to gain valuable insights, so don't miss out. Click the link now and take your learning to the next level. See you in the session.